Good noon. First of all, I thank Professor Sailesh Naik and Sivasji for invitation and giving an opportunity to share some of my thoughts on earthquake precursor that can be utilized for possible mitigation measures, and with some examples in Uttarakhand, Kumaon, Garhwal, Himalaya, I'll be showing how they will be useful. This is a very important workshop on understanding the earthquake risk in India. And I know that many in the audience are not expert into this seismology, and some of them are experts. So, to understand the precursor events, first of all, we need to have some sort of background understanding about this earthquake. So, just to give you a brief on that, how the Himalaya has been evolved, and that all of us know that the collision between Indian plate with the Eurasian, which initiated 55 million years back, has formed the mighty Himalaya, and the interface between the Indian plate and the Himalayan waves has been defined as the main Himalayan thrust. The geometry and subsurface nature controls the earthquake into the Himalayan region, and if we can see that particular main Himalayan thrust at which several crustal scale fault, Himalayan fault thrust, main boundary thrust, northern Almora thrust, and MCT, STD, the main central thrust, both Tibetan deities have sold, and they have divided the entire Himalaya into sub-Himalaya, lesser Himalaya, higher Himalaya, Tethyan Himalaya, and Tibetan Himalaya. And this has formed the youngest and most rough mountain chain into the northern part of the Indian part. So if we look into the earthquake scenario into the entire Himalayan arc, then we can see that in 1950 we have Assam earthquake, 1897 Ceylon earthquake, 1934 Bihar Nepal earthquake, and 1905 that is the Kangla earthquake. Besides that, we have some sort of 2005 Kashmir earthquake and 2015 Nepal earthquake, 1833 long back again Nepal Bihar earthquake. So if we look into the central part of the Himalaya, then we don't see any earthquake which has magnitude more than 7.5, and during the last 125 years we have not experienced like that. But if you look into the subsurface image, what I told that MHT plays a very important role to the earthquakes. Look into one of the profile into the Garhwal and another profile into the Kumaon Himalayan region, then we can see that the ram structure of the MHT and associated fluid into the subsurface plays a very crucial role for the generation of the earthquakes, seismogenesis of the earthquakes. If we look into the seismic section, there also we can see into the P2 profile that the ram structure has played a very important role for the generation of the earthquakes as well as the fluids. So we can understand that nature and geometry of the MHT as well as the presence of the fluid play a very important role for the seismogenesis into the Himalayan arc, and we can see at this region, there have been 1999 Chamoli earthquake. But we haven't seen any greater earthquake, we can say major earthquake into these regions. But if we look into the study taken by the Wadia Institute of Himalayan Geology from 2007 to 2022 into the Kumaon Garhwal Himalayan region, then we can see 4,563 earthquakes with magnitude more than 1.5 has taken place. And among them, only few are having magnitude Uttarkasi 6.6, Chamoli 6.4, Rudraprayag 5.7, and in the eastern part of the Pithoragarh, which falls into the western part of Nepal, has last year, December, 6.3 magnitude earthquake. But we don't have any 6, 7 magnitude or 8 magnitude earthquake into these regions. But if we look into the scenario of the Himalayan origin, where the subduction of the Indian plate beneath the Eurasian plate has taken place, and the convergence has been responsible for the changes into the physical properties of the subsurface that can be seismic velocity, resistivity, magnetic susceptibility, density, as well as chemical phenomena, emanation of the inert gas that can be helium, radon, carbon dioxide, geotechnical properties of rock deformations, water level fluctuations. These are taking place under the influence of the accumulated stresses. And we have observed before a main event takes place, there have been some sort of anomalous behavior. And that anomalous behavior we are defining as the precursors. So if we have the precursory study, we will be able to envisage what we are going to expect after some time. But for that, we have been doing some sort of research. So if we want to understand all the precursory events for the changes into several physical, chemical, and water level changes, we need to have some sort of stations at particular locations. So wherever we are expecting some sort of earthquakes, particularly into the central Himalaya, where we are expecting some sort of large earthquake or expecting some sort of major earthquake into these regions. So monitoring of such multi-parametric by setting observatories using multiple sophisticated instruments, real-time transmission of the data from the field to the processing center, analysis and processing of the center using artificial intelligence and machine learning, because it has to be done continuously. So we cannot depend on the human intervention. That has to be reduced, and artificial intelligence and machine learning can do that job, and we will be able to understand the precursory events, and that will help us to understand what is going to take place into that region as a measure of the mitigation caused by the earthquake disasters. How will we be able to know that which region of the Himalayan part is prone to seismic? For that, we have done extensive work for the identification of the potentially hazard zones. If we look into the continuous monitoring of the seismicity, high resolution, geometry of the MHT, I showed that MHT, that ram structure and fluid presence are very, very important to understand the seismicity pattern in the region. Identification of the lock zone beneath has shown in the frontal part of the Himalaya that entire Indian plate and overriding, they are locked, they are not able to move. They are just like he has shown two examples he has shown. I will come back to that. And then if we understand the delineation of the fluid and partial melt, that also helps us to understand, and the mapping of the characterization of the active faults, rheology and uptime. So if we look into all this study, then we will be able to say this is the most potential zone for the generation of the earthquake. So earthquake potential zone we can identify. So in that zone, if we constantly monitor into that vulnerable zone by looking into the spatial and temporal variation of the B values, I can show over here. So if we continuously monitor B values, if we find out the B value is reducing, it gives an indication that larger magnitude earthquake is envisaged into this region. Then plate movement, plate motion, deformation of the rock, that can be studied using GPS measurements. Variation of the VP-VS ratio, I am showing over here that if you look into the VP-VS ratio into this region, we can see that before a main event take place, there have been drop in the VP-VS ratio. Before a main event take place, there has been drop in the VP-VS. These are the precursory events. So we need to constantly monitor all those precursory events that will lead us to understand is something going to happen related to earthquake into that regions. Study of ground acceleration and anomalous behavior of several sets of multi-parameters that can be seismic velocity, resistivity, density, as well as emanation of some of the inert gas or some sort of water level fluctuations into these regions. Concentrating our research into the Kuma and Garhwal region, but from the GPS, we have established some of the GPS stations into that Uttarakhand Himalaya. And from the available GPS data, the GPS derived crustal velocities have been converted into standard pattern. And if we look into the standard pattern map into this region, then we can see into the higher Himalaya we have high standard pattern, and the lesser Himalaya and the sub Himalaya we have low standard pattern. And in the high standard pattern, you can see that this was the 1999 Chamoli earthquake, this was the 1991 Uttarkasi earthquake. And we have concentrated our precursory studies at this observatory into the Guttu. Professor Salesman mentioned that Guttu Observatory is constantly monitoring the multi-parameters. I'll show you some of the examples. So what we can see that more than 100 nanostrain rate in this region, we have seen a lot of seismicity. Even to big earthquakes, 1991 Uttarkasi, 1999 Chamoli. But if you look into the low standard region, we don't have much seismicity. So it is understood that into that region, some sort of lock zone is present and lot of seismic energy are accumulated that can come out in the form of earthquake later on as a great earthquake or some sort of a major earthquake. And the low standard two corridors we have identified which may be the probable locales for the future earthquake into these regions. So this is the study from the GPS we have done into the Kumaon and Garhwal Himalaya regions. If we take into this example, how the GPS study is helpful to understand the log zone and accumulated strain into the regions, we have several stations. So if we take a linear profile that has been shown into this Kalachand region, and this is some sort of topography variation, and we have also seen there are several cluster scale fault that MBT, MCT, STT, HFT, they have divided the entire Himalayan region into sub-Himalaya, lesser Himalaya, higher Himalaya, Tibetan Himalaya, and we can see that into the lesser Himalaya, if you look into the velocity is much less, but in moment it goes beyond that. So this 85 to 90 kilometer is completely locked, that beneath source. And the locked zone means during the last 125 years into this region, we have not experienced any major earthquake or big earthquake into the regions. And that shows that this is the zone, locked zone, and we have calculated this much locked zone is associated with 18 millimeter per year slip deficit or maybe convergence rate, and that can cause an accumulated slip of 9 meter and which is enough for the generation of the great earthquake. But we do not know how much of that energy will be released and when. So that is the main concern. If entire accumulated energy is generated, then we in the Kumail Garhwal Himalayan region is having the capability or potential for generating a major earthquake or great earthquake into that regions. And you can see from here that at this rate, if the accumulation rate or accumulation rate happens at this rate into the region, we are expecting to happen. But in the last 125 years, we have experienced some sort of major earthquake as well as moderate earthquake, and we have seen for each and every earthquake, there have been some sort of stress drop. Stress drop means it is releasing earthquake, it is releasing energy. But the releasing rate of the energy is much less than the accumulation rate of the energy which has taken place into the Kumail Garhwal Himalayan region. So we are suspecting this region has sufficient amount of energy which can be released in the form of the major earthquake or great earthquake in future. But again, we do not know when, and we do not know how much of that energy will be released. So we have studied some of the multi-parameters by setting a multi-parametric sensors into the Guttu by having BBS, GPS, magnetic observatories, accelerographs, and conducting gravitimeter, emission of the ULF, as well as groundwater level and radon monitoring. And I am showing some of the examples at the Guttu Observatory. If you look into the Garhwal Kumail Himalayan region, before the Nepal 2015 earthquake, if you look into the water table, there have been some sort of leveling, that before the earthquake there has been some sort of anomaly. We can radon alpha, there is some sort of anomaly. Radon gamma, there is some sort of anomaly. So all these precursory events show some sort of anomalous behavior before the actual event takes place. So if we comprehend, if we can understand how these physical parameter, chemical parameter are behaving into the subsurface by establishing sensors at a particular stations, at a number of stations, we will be able to understand the earthquake process or seismogenesis into these regions. Even on the gravitimeter, you can see one of the earthquake has taken place at 60 kilometers away, Kharsali earthquake 2007, and we can see there have been some sort of co-seismic changes. Even for that Nepal earthquake 2011, at a distance of 220 kilometers away from the Guttu region, there also we have observed. So these are the precursory events. If we can study, it will help us to understand the earthquake phenomena into the regions. If you look into these earthquakes into the Indian, because we are talking about the risk in earthquake risk in the Himalaya, then we can see with the passage of year, then the population has been exploded, population has been increased, and always we see there has been some sort of relation between the earthquake taken place in 1905 in Kangra. What was the loss of life? 20,000. If similar situation takes place now, where the population has been exploded 6 times, 7 times, and if that earthquake takes place into the early morning, the devastation will be too much. Maybe 2 lakhs people will be affected, or maybe many buildings will be damaged. And if we look into the Quetta in 1935 and Muzaffarpur earthquake, we can see huge number of lives have been lost because of the poor structures of this. So we need to understand with the population what will be the affected states. I will not touch upon this one. So, but some of the study in Russia, this Jagernik has done, and they have shown from the field experiment, from the laboratory experiment, from the theoretical studies, that if a region has a capable of generating 6 magnitude, 7 magnitude earthquake, they have injected electromagnetic wave into the field and produced weak magnitude earthquake, that means low magnitude earthquake, which doesn't cause any damage. So if we want to do that type of experiment, we need to understand, we need to do some sort of laboratory study, and if we do that, then definitely we'll be able to diffuse the energy accumulated by the subduction, accumulation taken place by the convergence. Is it possible? So we need to understand all sort of phenomena into that regions. And in the concluding remark, I would like to point out over here that we have dense coverage of the researchers, Professor Ravichandran, Dr. Professor Shailesh Naik, and Professor Saran Sahab also mentioned that at the present scenario, we have good network, we have real-time transmission of the data, first computing machines, advanced modeling, artificial intelligence and machine learning. Therefore, it is possible to prepare some sort of alert system so that will be used from the precursor study for the reduction of the loss. And if that accumulated stress energy into the subsurface can be diffused in the form of a non-hazardous weak earthquake instead of expected strong event, then also we'll be able to mitigate the hazards caused by the earthquake. But I'd like to mention what Bineet also has given two examples, that the snail and that another example, caterpillar GS7, that during the convergence rate, what exactly happened, the energy is getting accumulated and suddenly getting released in a fault zone. So that is we are defining as the stick slip. But is it possible through some exercise, through some modeling, to change the physical chemical properties of the fault, seismogenic fault, by which we will be able to transfer the deformation taken place from the stick slip to the slow earthquake or creep event that snail could not have that much energy. So is it possible to have some sort of slippery, some sort of other physical chemical change so that we'll be able to do that? And these sort of things will be able to do that. If we need to understand that, we need to do some sort of laboratory study, and this is the time that we should have some sort of laboratory study into our into different institutes. Thank you very much for your attention.
Excellent.